All right, so we're going to talk about the 240.87 with regard to the 2014 version of the National Electrical Code. Now, this would be, remember, 240.87 was introduced in the 2011 version of the NEC. So now we're getting into one cycle past that, and we're realizing, remember our discussion in the 2011 code was the title of 240.87 was non-instantaneous trip circuit breaker, non-instantaneous trip. And what we learned there was that this 240.87 was non-instantaneous trip. So what we learned there was that there's only one type of breaker. It's the power circuit breaker, and it's a very large power circuit breaker that has a 30 cycle delay all the ways up to the interrupting rating. And I rarely sell those, but the intent of the submitter was really around those larger overcurrent protective devices where there's a higher likelihood that the arcing current's probably going to be in that long time region. The 2011 version focused in on a non-instantaneous trip circuit breaker, but the code panel 10 is realizing that really, in reality, the incident energy is not just, you don't have high incident energy just because you have a large overcurrent protected device. Incident energy is dependent upon the available arcing current and its clearing time. I could have a 600 amp circuit breaker and have a very high incident energy because of the relationship between arcing current and the fast clearing time of the instantaneous. So the discussion at Code Panel 10 in the first draft was trying to address this. So they changed the title of 240.87 to arc energy reduction, which was a good step, a step in the right direction. But in the first draft, they made a change. They got rid of that non-instantaneous because they realized that power circuit breakers are the only ones that will not have an instantaneous. Most power circuit breakers still have an instantaneous, lower than their interrupting rating. Molded case circuit breakers and insulated case circuit breakers all have an instantaneous, but I make very large insulated case circuit breakers, and because of the relationship between the available arcing current and that instantaneous, which will be way over there to the right, it's a very high value for these insulated case circuit breakers. Because why do I make an insulated case circuit breaker? I got to hold the contacts closed longer for higher fault currents. I need beef around those contacts because I can't stand the chatter. And so the insulated case circuit breaker was developed as an intermediate step between a molded case and a power circuit breaker that would be able to fit into things like switchboards. Can't put a power circuit breaker into a switchboard. So a switchboard is that intermediate piece of equipment between a panel board and switch gear that's smaller, more compact. I can do more things with it. It's almost like a motor control center, but just a little different. So they realized in the 14 cycle that, hey, it's not just about the non-instantaneous trip. But then the first draft, they created language that was problematic because it would have required arc reduction technologies always down to a 15 amp circuit breaker. So I did a presentation to Code Panel 10 to help try to steer that in a different direction. And the only way to fix the language, which really wasn't that bad, it just needed a line in the sand. So my proposal was for 1,000 amp, draw the line in the sand at 1,000 amps, and make it such that any circuit breaker 1,000 amps or more, because that would align itself with 240 or 230.95 ground fault protection of equipment requirements that we find in 230, 210, and 215. But they didn't want the 1,000, and the reason we settled with 1,200 amps because the way the 240.87 reads in this cycle is where the highest continuous current trip setting for which the actual overcurrent device installed in a circuit breaker is rated or can be adjusted is 1,200 amps or higher. Then you have to do A and B. So they created a little architectural change in the layout they created two first level subdivisions. So arc energy reduction in 240.87 is set at 1,200 amps now. So now it's any circuit breaker, regardless if it's a molded case, insulated case, or power breaker. But if it's a circuit breaker, 1,200 amps or larger, Now you have a requirement for these technologies. Now, where did we get the language which says where the highest continuous current trip setting for which the actual overcurrent device installed in a circuit breaker is rated or can be adjusted? If you go to 230.95 in the National Electrical Code, ground fault protection of equipment. This says, if you read the second paragraph in 230.95, it says the rating of the service disconnect shall be considered to be the rating of the largest fuse that can be installed or the highest continuous current trip setting for which the actual overcurrent device installed in a circuit breaker is rated or can be adjusted. So what they're doing in 230.95 in this language, and what we did in 240.87 in that language, was we sort of circumvented the rating discussion in 240.6. 240.6 is titled Standard Ampere Ratings. And this is where, like in A, we have the table, tells you the standard ampere ratings for fuses and circuit breakers. B talks about when you have an adjustable trip circuit breaker. If you have an adjustable trip circuit breaker and you don't have C, which is the restricted access, the cover that is locked, then the ampere rating for that circuit breaker is whatever can be adjusted to. So I may have a 1200 amp breaker that's adjusted to 800 amps. If I don't lock the cover, if I don't follow the rules in 240.6C, which talks about restricted access, then that is still a 1200 amp breaker rated. But if I follow the rules in 240.6C and I have a bolted equipment enclosure door, or I have a removable and sealable cover over the adjusting means, or I have locked doors accessible to only qualified personnel, now that rating of that breaker, although it's a 1200 amp breaker, if I set it to 800 amps, I can put 800 amps worth of conductor and protect it thermally. That is an 800 amp circuit breaker rated as per the National Electrical Code. But 230.95 changes that because it says in 230.95, ground fault protection of equipment, it says the rating of the service disconnect shall be considered to be the rating of the largest fuse, which this isn't fuses what we're talking about, that can be installed, or the highest continuous current trip setting for which the actual overcurrent device installed in the circuit breaker is rated or can be adjusted. The or can be adjusted circumvents the 240.6. And we did the exact same language in 240.87. Why? Because the incident energy is not based upon the long time pickup of the overcurrent protective device. It's about the instantaneous. And if I take a 1200 amp circuit breaker that has an instantaneous of, 12 or 14 times 1200 amps, when I adjust the long time pickup down to 800 amps, I still have high incident energy. Why? Because I didn't adjust the instantaneous. 240.87, 240 or 230.95 and 215 and 210 and 240 ground fault protection of equipment 240.13 all tell you don't follow 240.6 when you're determining the rating of this device. For 230.95 and 240.13, that number is 1,000 amps. For 240.87, it's 1,200 amps. How do we get to 1,200 amps? When I did my presentation, I suggested 1,000. And somebody said, no, I don't agree with that. It should be 800. I had someone, because, I can have high instant energy on an 800 amp breaker. And someone else suggested, no, it needs to be 2,500 amps. And so they went back and forth, and 1,200 amps got consensus. So in sometimes to get a code change, it's not necessarily about the technical details. It's more so about what you can get that gets you 2/3 vote at the table. And then from there, it will keep changing. We saw that in the 2011 code. We got a non-instantaneous trip breaker that managed to get 2/3 vote. It wasn't perfect. This 240.87 is part of the 2014 code. Still not quite perfect, but at least it addressed the concerns that were initially instituted, because it's not just about a circuit breaker without an instantaneous. They put the 1,200 amps in as a line in the sand, and they said, okay, you know what? There's these things called active arc flash mitigation systems. So they kept all of the zone selective interlocking, the differential relaying is the same. The energy reduction maintenance switch with the indicator, local status indicator, is the same as it was in the 11 code. But then they said, there's these arc reduction technologies. I lovingly call them the crowbar, right? Because what they'll do is they create a low impedance fault inside the equipment when they recognize light and fault current. So they say, if you meet this recipe, then we are going to fabricate a short circuit that's going to trip and take these devices offline very fast. And some of these devices can operate. I mean, we have an arc quenching technology that'll operate as fast as a fuse. So, I mean, these things are just that good. And I've got some videos of that. Check out my YouTube site and you'll see in these discussions, and I'll try to put some links down below to help you understand there are other solutions on the market other than those they listed. So what they did was, in the 2014 code, they said, look, we're going to add this technology and we're going to create a line item 5 which says an approved equivalent means. So this recognizes if I come out with a new Van Ducky next week, that's the cat's meow when it comes to instant energy reduction, it should meet 240.87. Prior to 2014, I wouldn't be able to accept that technology, even if I proved it will do it, because it's not on the list. Now I have an approved equivalent means, which puts some weight on the authority having jurisdiction in their approval. So you're, as a manufacturer, as a solution provider, your technology, if it's not a listed solution, you're going to have to demonstrate and explain and convince the AHJ that what you have meets this requirement. So my suggestion would be, take your technology, calculate the incident energy at that equipment, take zone selective interlocking, calculate the incident energy at that equipment. If you can show that yours produces equal to or less incident energy, the AHJ would have a hard time proving that. You stamp it with your PE stamp, then it would be hard for the AHJ to say no. Okay, so there are ways to do that. They added an informational note that explains what an active arc flash mitigation system is. Our arc quencher technology is one of those. There'll be a link probably somewhere associated with this code change video. So that's what the 2014 code did with regard to the 240.87 requirements. And hopefully you got something out of this relatively short video on the code changes associated with NEC 2014 and specifically 240.87, which is now titled Arc Energy Reduction. Thanks. Take care.